So which one of the following crystal does not belong to the ditetragonal pyramidal class? So the data type question. So ditetragonal pyramidal class does not include the tetragonal dipyramid. You have to remember all the form. So a ditetragonal prism of first order, they all belongs to prismatic class, and this pedian also, C pedian, it will does not belong to pyramidal class. So tetragonal dipyramid will belong to ditetragonal pyramidal class. Sorry. So which one of the following crystal form does not belong to ditetragonal pyramidal class? You can say this prism of first order ditetragonal prism, they doesn't belong to the ditetragonal pyramidal class. Pyramidal class are tetragonal dipyramid and pedian. You'll find it in textbook of GBM or textbook of GB Mahapatra book. You'll find this. So group 1, you have to match for the composition. The leucite has composition KAlSi2O6. Then andradite, it is a garnet. So it will have a silicon oxidation 1:4. So it will be Ca3Fe2Si3O12 garnet. Cyanidine, it is orthoclase. Then KAlSi3O8. Then jadite, it is alkali pyroxene. So NaLSi2O6. So leucite, your KAlSi2O6. So this P is 3. Then Q, it is 4. Then R, it is 1. S, it is 2. The last one is the answer. And choose the correct pair of crystal system that represents the optic orientation shown in figure. X, Y, Z are principal optic vibration direction and A, B, C are crystallography axis direction. So in biaxial mineral, we will get 3 indicatrix axis, that is X, Y, Z, you can say vibration direction. Only in case of orthorhombic system, all the indicatrix axis will coincide with the crystallography axis, which you can see here in this diagram. All the axes X, Y, Z, they are coinciding with the crystallography axis. Here Y is coinciding with B axis, Z is coinciding with A axis, and X is coinciding with C axis. So this figure, it belongs to orthorhombic system. Then the next one, that is, you're in monoclinic system, only one crystallography axis will coincide with any of the indicatrix axis. Here B crystallography axis, it is coinciding with Y, and all other are not coinciding here. You can see this is the orientation of X, this is the orientation of Z, so they are not coinciding with A or C. So it will belongs to monoclinic system. So it will be orthorhombic and monoclinic system. So first one is orthorhombic, second one is monoclinic. And in triclinic system, none of the indicatrix axis will coincide with any of the crystallography axis. The answer will be orthorhombic and monoclinic. Then which of the mineral among the following represents Ab2O4? Ab2O4, remember, this is the general formula of spinel group. This is the general formula of spinel group. The spinel group, it includes spinel, magnetite, chromite. These three, they are included within the spinel group. Next on to 22 question. In the hollow symmetrical classes of cubic system, how many more faces does the 1-1 knot form have compared to 1-1-1 form? So 1-1 knot form, it is your dodecahedron. Hadron. So it has 12 number of faces, and 111 is your octahedron. So octahedron has 8 number of faces. So dodecahedron has 4 more number of faces than octahedron. So answer will be 4. Then realgar and orpiment are both mineral of arsenic and have the same chemical composition. Both have same chemical composition. Which one of the following properties can be used to distinguish between the two minerals? So realgar or orpiment, they are distinguished on the basis of their color. So realgar will find reddish or orangish color, and orpiment it is yellowish color. So color is the distinguishing property between realgar and orpiment. Then what is the minimum number of forms that an actual crystal must contain in class 1 pedial of the triclinic system? So minimum number of forms in class 1 or pedial class, remember it is 4. There are 4 number of form under pedial class. Which one of the given statement is correct? Van der Waals bonding is absent in silicate minerals. So van der Waals bonding, it is your very weak bond. The silicate, we have bond between Si and O. So the bond between Si and O, that is your, you can say partially or partly covalent. Partly covalent. Remember this is very important. Partly covalent, partly ionic. So the bond of silicate structure is partly covalent, partly ionic. So van der Waals bonding, that is also present in silicate structure. Sorry, absent in silicate structure. So van der Waals bonding, it is absent in silicate structure. You will only find covalent and ionic bond. So silicate bonds are partly covalent, partly ionic. Then sulfide minerals formed by covalent bonding between metals and sulfide. So it is a characteristic of sulfide minerals. It produces by covalent bonding and it produces between metal and sulfur. So most of the metallic things are sulfides. So this should be correct. Then silicate minerals have a significant component of metallic bonding. Silicate mineral doesn't have metallic bonding. Then metal sulfide formation does not involve splitting of d orbitals. So metal sulfide when forms because there will be covalent bond and there will be splitting of d orbitals. So this one will correct and all other three are incorrect. Then as the minerals group 1 with their optical properties, this is sodalite. Sodalite is a mineral that belongs to isometric system. So it will be isotropic. So it will be to tourmaline, it very important, it shows pleochroism. So pleochroic is tourmaline, which show pleochroic from blue to brown. Then calcite, it is main characteristic is a twinkling effect, like all other clay minerals, they also show twinkling effect. So R will be 4. Then moscovite, it shows motile extension or bird's eye extension. So this will be, so this is the characteristic. So P2, Q3, R4, H1. This one the answer. So which one of the following symmetry element is an incorrect represents of roto inversion operation? So we know 3-bar operation, it is threefold symmetry plus inversion. So it is correct because one A3 represents threefold symmetry and inversion, that will be produce 3-bar symmetry. Then 1 A2 equal to 4-bar. So this is incorrect because 4-bar operation it is does not equal to any operation. So this will be your incorrect and this will be the answer. Then mirror plane, we know 2-bar it is equivalent to a mirror plane. Then 6-bar it is equivalent to threefold axis by mirror plane. So A, C, D are correct, only B is incorrect. So answer will be B. So which of the following optical properties correctly identifies the apatite? Not one section. So apatite, it belongs to hexagonal system. Hexagonal system, and this not one section, it is basal section. So the basal section of a hexagonal mineral or tetragonal mineral is isotropic. So that's why the section will be isotropic under cross-nickel. Then it can show centered uniaxial interference figure. It can show centered uniaxial interference figure because of in basal section the optic axis is perpendicular to the microscope space and doesn't show secondary order interference color or doesn't have any high pi refulgence. So it will be A and C. The answer will be A and C. So basal section of any hexagonal or tetragonal mineral is, you can say, this is isotropic. So this is a previous year question, 2024. Which of the following is an amorphous variety of SiO2? So here is opal, it is amorphous variety. Agate, it is a concentric variety. Citron, it is yellow quartz, the crystalline variety. Okay, quartz is also a crystalline variety. So opal, it is your amorphous variety. Amorphous variety will not find any grain. So or crystal, you can say amorphous variety of silica is opal. So match the following mineral group with highest order interference color for 0.03 mm mineral thickness. Here you remember always quartz show fast order. Okay, quartz show fast order. Then sillimanite it show second order. Sillimanite show second order. Okay. Then moscovite it show third order, and calcite it will show greater than third order. So this thing will be known from the birefringence. Calcite has higher birefringence 0.142, and all of other like the quartz has very less birefringence 0.009. So from that you have to remember. Otherwise you have to remember the simple order of interference color of individual minerals. So answer will be P2, Q1, R4, S3. So crystal form dome contains. So dome is a form which has two non-parallel faces and they are characterized by a mirror plane. So two non-parallel faces related by a mirror plane. If they have two non-parallel faces related by a two-fold axis, then it will be sphenoid. So answer will be D, and this thing will be sphenoid. And only you have two parallel faces, they are called as pinacoid. Pinacoid, only two non-parallel faces. If you have two parallel faces, this is pinacoid. If you have two non-parallel faces, it is dome or sphenoid. Dome is characterized by a mirror plane. Sphenoid is characterized by a two-fold axis. Then the symbol, you have to remember this. A square bracket, it always indicate an axis. So it will be line. Then this curly bracket is represent form, and this simple bracket it represent face. So square bracket, line, curly bracket, form, simple bracket, face. The answer will be D. Which of the following corresponds to a pyrogen group? Here CaMg Si2O6 diopside, it is belongs to Parisine. Then NaFe Si2O6 Azerine, it belongs to Parisine. Then this Ca2Si2O6, it is your CaSiO3. It is elastonite, doesn't belongs to Parisine, it is belongs to Parisinoid group. And this thing, it belongs to Parisine group. So these three A, B, and D, they belongs to Parisine group. So this is all about your MCQ and MSQ question starting from 2015 to 2024.